So tomorrow, or Wednesday, I should say, on the multiple choice, you'll have a domain question. If you see a log function, what do you know about the argument and how it's related to the domain? What types of numbers can we take logs of? Positive only, right? Only positive. So remember, the way that you find the domain of a log function is you take the argument, which is the thing you're taking the log of, and you say it's strictly greater than 0. So this goes back to the beginning of the year stuff. And of course, because we're creating an inequality, what are the only types of inequalities we could solve algebraically? Linear, right? X to the first. So when I set up my quadratic inequality by saying that's greater than 0, I cannot solve that algebraically, right? We solve it graphically. So we know that this function is a parabola that opens up. So if we factor it, and it should be factorable, x minus 2, x minus 3, that's still legal. You could still do that. What you cannot do, though, is then say that x minus 2 is greater than 0 or x minus 3 is greater than 0. That is where the problem breaks down. You'll get the correct wrong answer if you do that. It'll be an answer choice. So instead, you just use the factorization to get your two x-intercepts, which are at 2 and 3. And if you recall, the solution then should either be everything between the x-intercepts or everything outside of them. So if you draw it, you want to know what values of x is that graph positive. That means where is it above the x-axis? And it's obviously positive to the left of 2 and to the right of 3. Strictly to the right of 3 and strictly to the left of 2. So your domain is going to be negative infinity to 2 union 3 to infinity. If the parabola had opened downward, it would be everything between 2 and 3. So don't fall prey to the incorrect algebra. Make sure you know how to find domains of quadratics or anything that's not linear, right? You solve them graphically. We looked at a couple of questions in the previous section where the argument was like a radical function. You know how to sketch transformation of radical functions. So it does come down to finding the x-intercept, but you have to know what to do with those x-intercepts. So that's a review really from the previous section. Now we'll jump to example 7. You'll have several opportunities to solve log equations on the multiple choice. So here's what we're going to do. We're going to go ahead and isolate the log. That's what we want to do. Isolate log, and then we are going to exponentiate both sides. And then we're going to solve and check. Solve and check your solutions. The reason you want to check your solutions for log equations is simply because they have restricted domains, right? We can only take logs of positive numbers. And sometimes in the process of solving, you get quadratics which have extraneous solutions. So if you don't check your answers at the end of a log equation, you can get bitten again. All right, so if you look at this equation, we're trying to solve for x in the argument. Your goal is to get the log by itself. So if this were an Algebra 1 problem, it would just be 4 plus 3x equals 16. We're trying to isolate x. So, of course, back in Algebra 1, you would subtract 4 and divide by 3, right? It's the same thing here. You'd subtract 4 and divide by 3. So we're going to have, and I'll show it in baby steps here. You subtract 4 from both sides, and you get 12. You divide both sides by 3, and you get 12/3, which is 4. And now that you got the log isolated, now you want to get rid of the log. So you can exponentiate both sides. And what base should you use? 3, right? That's the base of our log. So this is what it looks like to exponentiate both sides. You have 3 written on the bottom left. So now 3 to the log base 3 of blob is blob, and 3 to the 4th is 81. And if you solve for x, you get 81 halves. And now you check. When you plug 81 halves in and you double it, you get 81. Is 81 a positive number? Yeah, that's all you're looking for. When you plug it back into the argument, you better get a positive number. And so 81 halves is the answer. So that was a really easy one to start off with. This one here, we've got 2 logs. Well, to isolate the log, you have to get rid of 2 logs and turn them into 1 log. So in this case, we have to condense first. There's no coefficients to bring up. It's base 10. So we bring out one log, and what do we do with the two arguments here? We multiply them. Good. We multiply them. So you get the product, x plus 2 times x minus 1. Now that we have the log isolated, now we exponentiate. And since this is log base 10, we'll exponentiate both sides, base 10. So the left side, we get 10 to the log base 10. A blob is just a blob, which now I'm going to expand that out. X squared, you're going to get 2x minus 1x is x minus 2 equals 10 to the first, which is 10. Now here's where we've got to be really careful on our final solutions. Notice we started off with two arguments that were both linear, x plus 2 and x minus 1, and now we've turned it into a quadratic. So this is where you're at risk for finding a extraneous solution. To solve the quadratic, remember, you got to get everything on one side and set it equal to 0. So that becomes minus 12, and now that it's equal to 0, you factor. And again, these should be designed to factor, so you don't have to use the quadratic formula. This should be x plus 4, x minus 3. And when you solve, you get x equals negative 4 or x equals 3. And before you box them up and walk away, plug them in, see if they work. If you plug in your negative 4, it's got to work in both arguments now. When you plug in a negative 4 to the first one, you get negative 4 plus 2. That is negative 2. So you got a negative number. It actually creates a negative in both arguments. But even if it was only one argument or it didn't work, it has to work for both to be in the domain. So that's your extraneous solution. If you plug in the 3, you get a 5 and a 2, both of which are positive. So 3 is in the club. Okay, but there will be an answer choice on the test where it has both of them listed. And you have to know which one works and which one doesn't. We're looking for just positive arguments in the end. All right, part C. Kind of the same thing. You got two logs. You got to condense it, but in this case, you got a 2 out front of the first one. So you could bring the 2 up and you could bring the 3 up if you want, but there's an easier way on this one. They're both log base 4, but what do you notice about the arguments in this case? They're the same. We haven't had that before. So these are actually like terms. If you have 2 log base 4 of that minus 3 log base 4 of that, what are you left with? What's 2 minus 3? Negative. So this is the easier way to do it. If you would have brought the 2 and the 3 up, it would work. When you condense it, they would divide out, and you still get the same answer. This is just kind of noticing it, that they're actually like terms. Now, we haven't isolated the log yet, so instead of bringing the negative up, let's just multiply both sides by negative 1, and that turns it into a negative 1 on the right-hand side. Now you got your log isolated. Now you exponentiate both sides, base 4, and you end up with x minus 5 equals, what's another name for 4 to the negative first? 1/4. Yep. So now if you add both sides, you get 5 1/4, which is 21/4. And there's your answer. Oops, I boxed it. I didn't even try it. We better try it. If you plug 21/4 in, what's 21/4 minus 5? 21/4 is the same as 5.25. So minus 5 still makes it positive. So it works. It's actually the solution. So let's look at it the other way. If you didn't recognize they were like terms, and you brought the 2 and the 3 up, that would be log base 4 of x minus 5 squared minus log base 4 of x minus 5 cubed equals 1. It's another way to do it. Now you'll condense, and you know you have a negative term, so you have a denominator. So the numerator is x minus 5 squared, and the denominator is x minus 5 cubed, and that equals 1. So now if you exponentiate both sides, you're going to get 4 to the first, which is 4 on that side. What do you notice happens in here? 2 of those x minus 5 factors divide out, right? Leaving you 1 over x minus 5 cubed. And now, since you have a ratio on each side, a proportion essentially, you can flip both sides. So you get x minus 5 cubed equals 1/4. Oops, it's not cubed anymore, sorry. We divided it out. That was my bad. And so x minus 5 equals 1/4. And now if you add 5 to both sides, you get 21/4 again. So you'll get the same answer. And then, of course, you'll check your answer and make sure it's right. I think we have time for one more here. Notice this one has 3 logs on part D. When you have to isolate your logs, you isolate them on either side. So you can have one log term and one log term on the other side. So if you condense this, again, you're going to multiply 3x minus 2 times x minus 1, and that equals the natural log of x squared by bringing the 2 up and condensing these. Now, since they're both natural logs, we'll exponentiate it, and if we multiply those out, you get 3x squared minus 2x minus 3x is minus 5x plus 2, and that equals x squared. So now you collect your like terms, and you're left with 3 minus x squared, which is 2x squared, minus 5x plus 2 equals 0. So notice again, we started with 2 linear arguments, or 3 actually, and none of them were quadratics, and now we have a quadratic. So now we'll factor this one. That factors as a 2x and an x, and then it has to factor as a 2 and a 2, and they both have to be minus 4. Does this one factor? It's got to be a 2 and a 1. So that would be a 1 and a 2, and that would be a minus 4 minus x. So there's the factorization. They should factor for you on the test. So now you get x equals 1/2 or x equals 2. But you try them out. When you plug in a 1/2, what do you get when you plug a 1/2 into this one right here? 1/2 minus 1 is negative. That's no good. So the 1/2 is out. If you plug the 2 in, to the first one you get 4, to the second one you get 1, and on the right-hand side you get 2. So 2 is the only answer that works. All right, so we'll stop right there. We got through 7D. Tomorrow we'll do the free response 20-minute test, and then we'll get back to these notes here and just proceed a little bit further through the notes. You still want to practice 4.5 worksheet because there's a lot of questions in there that you could do, but you're not going to have to turn it in. So if you borrowed a calculator today, make sure you turn it back in. And maybe, yeah, that's good.